Okay, part A doesn't really work because if x is a multiple of 3, like 6, then x over 3, which is 6 over 3, which is 2.0, that can't ever equal the fraction part of that, because the fraction part of that is 0.0. So we're looking for tests that will not determine if x is a multiple of 3. A definitely qualifies. It does not work. All right, let's try B. All right, part B. If this is true, will that guarantee that x is a multiple of 3? Well, let's try a value of x that is a multiple of 3, like, for example, 9. All right, let's try 9 divided by 3. That gives us 3. Now let's compare that to the integer part of 9 divided by 3. That's the integer part of 3, which is just 3. So if x divided by 3 is the same as the integer part, then that will be a multiple of 3. So B works. Again, we're looking for the ones which do not work. B does work, so that won't be one of our answers. All right, next let's check C. Part C says, is the fraction part of x divided by 3 equal to 0? I mean, if the fraction part of x divided by 3 is 0, will that necessarily mean x is a multiple of 3? And this works too, because if x is a multiple of 3, then when we divide 3 into it, there will be no remainder, and the fraction part will be 0. So that does tell us if x is a multiple of 3. All right, what about D? A multiple of 3, for example, 9 or 6 or 12 or 15, they're multiples of 3 because they're the result of 3 times some number. 6 is 3 times 2, 9 is 3 times 3, 12 is 3 times 4, 15 is 3 times 5. So if we're wondering if x is a multiple of 3, then if it's equal to 3 times something, then it is a multiple of 3. So the loop lets m equal 1. And so we'll check if 3 is equal to x, and then m is 2, which means is 6 equal to x, and then when m is 3 is 3 times 3, which is 9 equal to x. When m is 4, it's asking if 12 is equal to x. So this will check to see if x is a multiple of 3. So that does work. We're looking for the nots. So C works just as well as, or D works just as well as C and B. Finally, we need to check E. E does not work because, for example, consider when x is 6. We know that that is multiple of 3. What's the fractional part of the cubed root of 6? Is the fractional part equal to 0? This is asking basically for the fractional part of the cubed root of x, which is the same thing as x raised to the 1/3 power. Which is the fraction part of 1.817 approximately, which is approximately 0.817. That's the fractional part. Well, x is a multiple of 3. 6 is a multiple of 3. And the fractional part isn't 0. So E isn't going to work. And since E does not work, and that's what we're doing, looking for ones which do not work, our answer is A and E.